In part 2 of the Structural Geology Lab, you are asked to draw a geologic cross-section from map information, particularly ortho image, aerial photograph essentially. And this is the photograph that we're going to be working with. You'll notice a couple of things about it. You'll see the layers. This is an area in central Wyoming where, again, there's very little vegetation, and so the rock units crop out at the surface and are easy to see based on their difference in color and weathering characteristics. You'll notice some streams that have eroded through these rock layers, and they've formed V's, and that will help you determine which way these rock layers are dipping. This is a plunging fold. Notice the overall V-shaped in this. You can compare that to the plunging fold models earlier in the lab. Other information that's on this map is the rock ages, and the rock ages are indicated by symbols. The C, TM, F, QAL, and they're referenced to information that's given in the instructions above this ortho image. So remember that rock ages can help us determine the type of fold we're looking at as well, because oldest rocks are contained in the center of an anticline and younger rocks are contained in the center of a syncline. You're going to draw your cross-section in this empty rectangle that is above the image. And the cross-section will be drawn along the line XY. You'll need a scrap sheet of paper for this exercise, and I'm not going to complete this one. I'm just going to show you where you'll be placing along the line XY, and everywhere there's a contact between two formations, you're going to make a mark, and that mark would need to dip either to the right or to the left of the page, depending on which way you've determined these rock layers are dipping based on the rule of V's and the ages of the rock. When you have your marks on this page across here, then you'll bring it up to the empty block above, and you'll transfer those dip marks to this block, and then you'll sketch in whether it's an anticline or syncline or what particular type of structure it is. Now, I have another map that I'm going to actually work this on. This exercise is not from your lab manual, and this is not an ortho image. It's a geologic map, which actually conveys similar information. The different colors that you see are different formations where they outcrop on the surface. This is from an area in Montana called Devil's Fence. And it's also a plunging fold. We know it's a plunging fold because of the V shape or the U shape in the map view. And I'd like to draw a cross section across this line. There are a couple of pieces of information that I can use to do this. The ages of the rocks in the center of this diagram are the oldest. So I'm going to draw an O there to represent old. Other information that you may be able to see are strike dip symbols. In this case, the dip is pointing to the east, and on this side it's pointing to the west, and that's consistent all the way across this structure. The dips are pointing away from each other, and that happens when we are looking at an anticline on the surface. So the dip angles here are on the order of 30 to 45 degrees. So everywhere there's a contact, I'm going to place a little mark on my piece of scratch paper that dips in the proper direction. In this case, they're all pointing to the west, so these lines are going to slope off to the west. And I'll come back on the other side. Now, the center of the anticline is actually right here, so these beds are going to dip back to the east. So I've roughed out an anticline in this case. If I were to draw the complete structure, I could draw dotted lines above the surface where these rock units used to be, but they've been removed by erosion now. and extend them in the subsurface for some direction. And I assume that underneath here there is a bottom layer that never outcrops at the surface, like so. So in this little exercise, we've taken information from a geologic map or an ortho image, and using rule of V's and strikes and dips, we've determined what kind of structure is represented on the map, and then we've drawn ourselves a geologic cross-section.